Okay, this was where we stopped yesterday. We proved the change of base law for logarithms, meaning to say that if I have this, for example, okay, if I have log of x to base 2, okay, log of x to base 2, okay, and I don't like the base 2 because it doesn't help me to solve the question or evaluate the value. Okay, I can change it to whatever base I want in order to help me to solve or to evaluate the expression. Okay, now let's say I want to change to base, oh, in this case, okay, let's say I change to base 2 lah. I show you if I change to base 2, right? The numerator will still be log of x to base 2, but the denominator, you can actually change it to something. All right, if you think about it, this log of 2 to base 2 actually is asking us 2 to the power of what is 2. Okay, I hope you remember this. So 2 to the power of what is 2? Answer is 1, right? That's why the answer is just log of x to base 2, which is the same. I'm just trying to give you an example to show that the change of base, okay, is actually, if you change it to the same base 2, you get back the same thing. That means this change of base method works. Okay, I've already proven in this form to you. Now let's look at another example. Again, this same old log of x to base 2. If I want to change it to base x, then what will happen? Okay, the argument will just stay here at the numerator. The base will be at the denominator. Okay, and then I change it, the red color, the base to whatever I want. Okay, and in this case, it is x. So if you again look at the expression in the numerator, what we're trying to ask you is x to the power of what is x? So the answer must be 1, right? Because x to the power of 1 is x, right? Okay, now how about the denominator? Denominator, x to the power of what is 2? We don't know, you see? Because we don't even know what x is. So we leave it as it is. Okay, so you see, this and this, they are equivalent. Log of x to base 2 is actually the same as 1 over log of 2 to base x. Must you memorize this? No need. You can simply use the change of base to obtain this if you need to. Okay. Now, why would we want to change the base? You will understand when we go back to solve the question 2, which we spoke about yesterday. Okay, so I just give you a few more examples. Log of x to base 4, if I want it to become base 2, I change them to both to base 2, okay, at the numerator and denominator, and the argument is at the numerator, base is at the denominator, okay? And you see, there's nothing much I can do to the numerator, right? Because I don't know 2 to the power of what is x, because I don't even know what x is. But for the denominator, if your argument and your base, they are both numbers, then you will be able to tell that 2 to the power of something, okay, 2 to the power of something can be equals to 4, right? And what's the answer? 2 to the power of 2, right? So the answer for this log of 4 to base 2 is 2. So this is your answer for this, or not say answer, like it's an equivalent form for this. Okay. Now, how about if I have this? Okay, if I have this, log of x to base square root 5. Now you see, normally we don't want to work with square root as the base, all right? And this forms like part of a bigger equation. This just this log. Okay, so I probably may want to change it to base 5. Okay, again, the x remains on top, the base is at the denominator. All right, the first thing you look at is the numerator. There's nothing much you can do here because you don't know 5 to the power of what is equals to this unknown. There's no way to know, right? Because this unknown can be any number which we don't know. Okay, so you can only so-called evaluate a logarithm with a known number at the argument and a known number at the base. Okay, So 5 to the power of what is equals to square root 5. Now you know that this square root 5 is actually 5 to the power of 1 over 2, right? So 5 to the power of what is equals to 5 to the power of 1 over 2 must be half. Okay, so this is your half. And then this divided by half is actually flip the half, so it's 2 of this. All right, so actually we are going to revise the power law this morning. Power law means if you have a number 2 in front of the logarithm here, right, you can actually bring this number up to the power here. That means this is equivalent to log x. Bring this number 2 up here to the argument, right? It will be x squared, okay, to base 5. All right, similarly, you can bring this power down back to here. So this is what we call the power law. All right, now I'm going to show you so far what we have done already, okay? Just a summary. So far, you have learned that index form, okay? Index form can be written as like a number equals to a base to the power of an index, right? But there's another way to express this index form, and that is called the logarithmic form. How to find how to write the logarithmic form of this? Very simple. The base, you write it at the bottom of the log here. Okay, and for the argument is actually the answer to this a to the power of x. So this reads as log of y to base a equals to x. This x is the index, and this a is the base. So you think of it as a to the power of x equals to y. A to the power of x equals to y. Okay, so that's how you do it. You need to be able to change from this to this and this to this. Okay, and there are a few rules that you need to remember. The argument, in this case, I write it as y, cannot be less than 0. That means cannot be negative. Cannot be 0 also. Okay, as proven to you yesterday. And the base cannot be equals to 0 and cannot be negative. Okay, so these two numbers must be positive line, in other words, cannot be 0. Okay, and your a, okay, although must be positive, it cannot be 1, because 1 to the power of anything will still be 1. So it's like not defined. Okay, now that's the first thing we learn. And we also learn that if you have log of a to base a, the answer will definitely be 1. That means log of whatever number to the same base, then the answer will be 1. For example, log of 17 to base 17 definitely is 1. Okay, so whatever this can be p, it will be 1. Z, it will be 1. Okay, so that's the first thing. And log of 1 to any base, log of 1 to any base must be equal to 0, because a to the power of 0 is 1, or any number to the power of 0 is 1. Okay, so that's what we have done so far. And I just revised with you change of base, right? Change of base. So let's say you are given this log of b to base a, and then you don't like this base a because it doesn't help you to solve the question. You can change it to base c. Alright, that's what we did. Okay, now the next one we're going to explore is what we call the power law. We did that when we were doing the question yesterday. This question, remember? Here, right? Then I told you you can bring this base of the argument down. Bring this, not bring this base, bring this power of the argument down. Bring this power of the argument down to the front of the logarithm. Okay? Yeah, so this is called the power law. Now the power law simply says this. If I have log of b to the power of r, this is the argument. This whole thing is argument, okay? If the base is A, okay, then your base will still be A. You only need to bring down the R, power of the argument. All right. Now maybe I should put this here clearer. So the power of your argument, you can bring it down. That's all. Okay, so that's called the power law. Let's take a look at the power law. Some examples here. The first one is done for you already. You can take a look. A log of x squared to base 3 is equals to 2 log of x to base 3. So I want you to have this habit to see that, okay, you square this, okay, so you can bring this down. That's all. All right. Now, how about the reverse way? The reverse or the converse way is also true. You can bring this power up to the argument, which is x. So that's all you have. Okay. And how about this? Okay, this is testing you on your understanding. You know that argument is x times y, right? And then when you bring it up, you have to know that this power 3, okay, it's actually you're cubing the x times y. You're not just cubing the y. So this is a very common mistake, which means that the overall result of this is log of x cubed y cubed to base 2. Okay, so that's something you need to bear in mind. It is not that the 3 only belongs to the y. No, the 3 belongs to the whole argument x times y. So this is the result. Okay, now let's look at the next one. How about this? Okay, this one, some of you might be tempted to do it this way. You see this 5, right? Then you will bring down the 5. Like that. Okay, now this is wrong. This is wrong. Why? Because you take a look at it, right? This 5 only belongs to the x. But there is the whole argument, right, actually consists of 32x to the power 5. So you cannot simply bring the 5 power 5 of x down, okay, and then totally ignore 32. Cannot. So what must you do? You need to make sure that they both have power 5. Okay, there's another way to do this. I will explain later once I've gone through some other laws with you. Okay, so you know that x to the power of 5 is x to the power of 5 lah. What to the power of 5 is 32. If you remember, is 2 to the power of 5 is 32, right? Okay, so this is what you need to do. You need to make sure that the argument has the same power of 5. So I change this 32 to 2 to the power of 5. X to the power of 5 to x, of course, to the power of 5. All right, now you are ready to bring it down. Bring the power down. Like that. Okay, so this is how you should do this question. Now, the next one. The next one, same thing. You cannot simply bring the 3 down to the front, meaning like that. You cannot do this. Okay, this is wrong. Sorry. This. Many of you would just simply bring the 3 down and then 8x. No, cannot. Okay, you have to make sure that the whole argument is raised to power 3. So it's like that, right? This is equivalent to this, right? And then only then you can bring down the power 3. Sorry, that's all. Okay, so I hope this clarifies this concept of the power law. Okay, now the last two that we're learning, right, is what we call the product law and the quotient law. Now product means times. So if you have log of x times y, that means the argument you have something times something, right? This is actually equivalent to log of x plus log of y. oh sorry, I wrote wrongly. It is base A. Okay, so if you have your argument being multiplied together xy, right? When you split up the log, right, it's actually addition. Okay, I'm going to prove it to you. Now, I haven't proven to you the power law, right? Okay, let me prove to you the power law first. Okay, I'll prove to you the power law, then I'll prove to you the product law and the quotient law. Now, you need to know all these laws really by heart, and they must be at the tip of your fingers, okay? You will not be asked to prove these laws, but I'm proving to you so that you are convinced that they are true and that you can apply them with confidence. But now let me just prove to you the power law first. If you are given log of b to base a, okay, log of b to base a, then then how do I proceed? Okay, what I can do is I can let this whole thing be equals to y. Okay, this is a very common starting point for proving, right? Why do we want to do this? So that we can change this into the index form. You see, a to the power of y is b, correct? So index form, after that, right, we will come back again to logarithmic form by before that, raising the power of both sides. We power this side up by r, power this side up by r. It's like squaring both sides. But in this case, we don't know what this r is, okay? Or cubing both sides, something like that. Okay, so if I raise it to the power of r on the left, I must raise it to the power of r on the right. Okay, so the new thing that you see here is r. I hope you notice that. Okay, now after that, you see, we are proving the power law of logarithm, right? So we need to come back to logarithm. The whole idea of going to this index form is to do something there. What thing? Later you will see. So when I change this to a log, how do I change? Okay, so you see, this is like my base, correct? Just now this is like my base, all right? Okay, so this is still my base. You can think of this as the base b also, but based on our original equation. So you see, when you do proving, you must really know what's going on. Don't blind blah blah go and do. Your original base is a, so this must be your original base. Okay, and this is your index. Okay, so when you write as logarithmic form, it must be log of this answer to base a, which is like that. Log of this answer to base a must be equals to the index. This whole thing is the index, correct? Then now you see already. Now you see something familiar already. Log of b to the power r to base a equals to r times y. But what is y? Our y, we actually let it be this just now. Okay, so this is my y. So you see, proven already. Log of b to the power r of base log of b to the power r to base a is equals to, you bring the r down to the front. See, then everything else remains the same, correct? So we have proven already. We have proven the thing to you already. Okay, don't forget, this r, the power, okay, belongs to the argument. Okay, it's not belonging to the log. What do I mean? Next time I will tell you again. Okay, so you just remember the r, this power, right, belongs to the argument, not to the log. Okay, now that's all for the proving. I will now show you the proof for the product law. Okay, what does the product law say? Product law says this. Okay, product law, just now I mentioned already, using this summary sheet. I will take a snapshot of this for you. Okay, now log of xy, log of x times y lah, to base a, right, is, you can split this up, is log of x to base a plus log of y to base a. So I'm going to prove this law to you now. Okay, but probably before I prove it, I show you exactly what I'm talking about. Otherwise, you may not know what I'm talking about without actual numbers. So I'm giving you some actual numbers. Now, what I mean by the product law is this. If you have log of 4 times 8 to base 2, I can actually split this whole argument, right, into 2 logarithm. Okay, I split this into 4. I split this into 8. But they are connected. The 2 logarithms are connected by a plus. It's not a times here, okay? It's not a times here. Why is that so? Okay, I prove to you using numbers first. Okay, let us try to work out the equivalent form of this. Log of 32, right, to base 2 means 2 to the power of what equals to 32. So answer is equal to 5, right? Correct? So the left hand side actually is equals to 5. Okay? Now, let's see when we apply this product law whether we end up with the same answer or not. 2 to the power of what is 4? Okay. You can pause the video anytime. Then plus 2 to the power of what is 8? You see, isn't the answer again 5? So this proves that the product law works. Alright. If you were to write multiply here, then of course it's wrong already. 2 times 3 is 6, and it's not equal to 5. Clear? Okay, let's do some very simple stuff. So if I have log p times q times r to base 2, is actually like that when you split it up. So times for the argument when you multiply, right, is actually adding the individual log. Now, how about the next one? Next one, I'm just trying to tell you that you have to be very flexible. This one means this times this, this times this. So it's like that. Then I want you to know how to apply the power law also. Remember I told you this means power p to the power 1, this means root 2, right? So it is p to the power half. Half I can bring down, right? So it's like that. Then this one, the 2 I can bring down, right? So it's like that. Okay, clear? We are applying 2 laws in the same line of working. Okay. Now, quotient law. Quotient law, I haven't shown you the general form yet, but I show you the numerical form. Let's say I have log of 64 divided by 4 as the argument. Okay, to base 2. What do I do? Now, when you have division, that's where the name quotient came from. Quotient. You divide, then you get a quotient and all that, right? Okay, so when I split this into 2, it'll be log 64 to base 2 minus log 4 to base 2. Oh, by the way, the base must be the same. Okay, the base must be the same. Okay, so let us try and work this out. Just like this example, we prove using numbers. Okay, 64 divided by 4 is 16, right? So 2 to the power of what is 16? 4, right? Okay, you pause the video when I ask you question, then you pause. 2 to the power of what is 64? So answer is 6, right? Okay, then 2 to the power of what is 4? 2, right? So 6 minus 2 is 4, right? So actually the quotient law works. When you divide when you have division within the argument there, right? You must minus. When you have multiplication within the argument, you plus. Okay? Let me just show you some more example. Now, if I have a combination like that, so when you divide, you minus. Okay? When you that means when you are at the numerator is a positive lah. When you are at the denominator is a negative. Okay? Of course, you can write this as 2 log p, log of p to base 2 minus log of q to base 2. Alright? Okay, how about this? Same thing, same old story. Remember, your base must be the same when you apply this law. Okay, so we have done the product law, quotient law, and actually almost all the laws. Okay, so let me generalize it. The quotient means division. You must know this name quotient because next year in the topic called differentiation, you will have this quotient rule. Okay, so you don't get mixed up. Okay, this is the general form. When you have log of xy, that means x divided by y, to base a, it is simply log of x to base a minus log of y to base a. That's all. Alright, you must know how to apply this. Okay, let me prove to you in a formal way. Just now all this it's not a formal proof, We're only proving it to be true for one number, We're only proving it to be true for one number. So these are not considered formal proofs. That means if I say proof the quotient law and then you show me this, you will get 0. Because this is only one particular value. So no, cannot. So what is the formal way to prove this? This is the formal way to prove this. Okay, so I want to prove that the log of x times y to base a is equals to the log of x plus the log of y to base a. Okay, so that's what I want to prove. Now, how do we start? Remember, it's always going back to the same old story. Indices, index form, right, and the logarithmic form, they are very closely related. Okay, you have to make use of one to prove the other. Okay, so that's what I'm going to do. I'm going to let this be m. So this one, log of x to base a, right? I let it be m. Log of y to base a, I let it be n. After that, right, you see, I can write a to the power of m equals to x, correct or not? Or x equals to a to the power of m. So we are converting from log to index form to log form. Okay, again, similarly here, this is the base, right? This is the index, right? So a to the power of n must be equals to this argument y. Okay, now what's the purpose of doing this? We are trying to find out what x times y is. You see, there's x times y here, you see. So what is x times y? It is a to the power m times a to the power n. And you learn in sec 3 is a to the power m plus n, like that. That means x times y, this argument is actually this. So far so good. Okay, now I'm going to change to log. Don't you agree this is the index? Sorry. This is the index. This is the base. Okay, and then of course this is your argument, right? So log of xy to base a must be equals to this index. Agree? Okay, but what is m? M is this one. You see, it's the same old proof. Then the n is this one. So you put them back. That proven already. Okay, so log of x times y to base a, you split it up. It is log of x plus log of y to power to base a. So that's all. Okay, quotient law is the same thing. I just flash very simple one. Same old story. I want to prove this, right? I let this be this, and I let this be this. Then I change it to index form. Then, because now I want x over y, right? X over y, so I find the x over y. And then later I convert this and this, okay, ignore this, this and this into the logarithmic form. And then I change the m and the n back. Finish already. Okay, So that's how you do the proving. Now that you know all the laws here. This one is the most basic, you must know. Okay, I'll take a picture for you later. Okay, no need to copy. Then this one is like special values. Actually, no need one, common sense. Okay, then this one, change of base, you must know. Where you must use change of base later, you will see in the question. Power law is when you have a power here, then you need to bring down. Why must bring down? So that it can simplify. You can add. Okay, I will show you when we do the questions. These two are the most common. When you have something multiplied together at the argument, you go and add the log. Divided at the argument, you go and minus. That's all. Okay. Rule of thumb is if I'm at the denominator, my log, the coefficient is negative. If I'm at the numerator, positive. Okay. Now let's do question 2. Wow, we spent 2 days to do 2 questions. Okay. So let's get to that question now. You were given this question, I think last night. Okay, so solve the equation, this one. So you may want to pause the video and then try using the so-called summary of the laws that I will be sending you, okay? Or which I already had sent you by the time you see this video, okay? Now, how do I solve this? Solve means find the unknown, right? So I have log of 1 minus x to square root 2 equals to 1 plus log of 2x plus 4 to base 2. So how? Okay, and then you think about it. Just like in indices, right? Just like in indices, when your base is different, you will have a problem, right? So now you see this logarithm, the base is different. So don't you think that something here which you have learned just now would come in handy? How do I change the base, this square root 2 to something easier like 2? Okay, hey, don't be silly and change this to square root 2, then you complicate your whole expression. Okay, so can we use the quotient rule, product rule, power? Don't even have power. So don't bother don't bother, okay? Or do we use the change of base law? Maybe you can use a change of base law, right? Okay, and this is the whole story Actually, the whole topic is roughly like that. Okay, so maybe I can change this the left hand side, right? I change it to log of base 2. Maybe that's a good idea. So log base 2. This is how you do it, log base 2, right? You want base 2, so both the numerator and the denominator must be base 2. And the argument is on top. The base is at the numerator. Alright. Now I can write this. Remember I told you this 1, this 2. I can write it as 2 to the power of half, right? Okay, that will help you to see what the answer is very clearly. Okay, then this one is a problem, because I want all the base to be the same, right? Okay, but never mind. We do that one later. We do step by step, okay? Yeah, so far so good. I think so far so good, right? You only change this base to base 2. Now, is there anything you can do at the numerator? There's nothing much you can do because of this unknown x. So you don't know what 2, you don't know 2 to the power of what is 1 minus x because you don't even know what is x, you see? So you can only attack the denominator because this is a known number, this is a known number, so you can find 2 to the power of what is 2 to the power of half. Answer must be half, correct or not? Yeah, so this must be at the numerator must be half. Then actually this divided by half is actually flip up lah. So it's actually is a 2. Oh, so actually you don't waste time, can you know that it's a half at the bottom, it's actually a 2, but never mind. I show you this first, step by step, because this is the first time you are doing this question. All right, so you flip the 2 up, flip the half, and then it becomes a 2 log 2 1 minus x equals to 1 plus log 2x plus 4, right? Okay, don't have to be so lengthy. You can cut some steps, but because it's the first time, so I'm doing things slowly. Okay, so far so good. Yeah, so far so good. Let me just continue. Oh, now we have a problem because the thing is this, this is log base 2. Okay, that's very good. This is log base 2. That's very good. But then this is a 1. Huh? And how do I change this to log base 2? So I think about it, right? Log base 2. 2 to the power of 1. Because this is the index, right? 2 to the power of 1 is 2. So the answer should be like that one. That's why I told you already. This one, actually we're applying this log of A to base A equals 1. But I told you already, it's common sense. Common sense. You see, if you know this very well, it's, all these things are common sense. You see, log this 2 to the power of 1 is what? It has to be 2 log. So this argument must be 2. Okay, so let's settle the right hand side first. Can you see that now, because log base 2 plus log base 2, we can combine these two into, okay, I do the right hand side first. By right you shouldn't be doing this, but I am showing you step by step on the right. Can you see that this is just log x times y to base 2 equals to log of x to base 2 plus log of y to base 2. Can you see that? Okay, but now on the right hand side we have a problem, because why problem? Because there's a 2 here. So the whole idea is I want log of 2 to something, then equals to log of something to base 2, then I can just compare the inside. You know what I mean? I cannot have a 2 here, because if I have a 2 here, then these two are not equivalent already. You know what I mean? Not? I cannot have a 2 here. Okay, so I have to bring the 2 up to this argument here. So this will give me 1 minus x squared. Now I can so-called say that because this is log base 2, this is log base 2, so this inside, whatever is inside this argument, right, they must be equal, what? Correct or not? But just now when I have a 2 here, then I cannot say that they are equal, you see? So that's why I have no choice but to bring the 2 up here. Alright, okay, now we can get rid of the log already. Then you can expand, you can expand all this. Then go and do your ding ding dong dong, your sec 2 work, okay? So that's the end of this lesson. This is the solution. You go and check it out. This question is worth about 4 marks. So you go and check, okay? You see, I reject this answer. Why? I told you already, I think yesterday. Whatever answer you get for logarithm, or for that matter for algebra, right? Or whatever you solve, you must always check your answer. Do they satisfy the original equation? So why is this rejected? Okay, so you see, when I put minus 1 inside here, 1 minus minus 1 is 2. So this is positive, it's okay. The argument must be positive, okay? But when you put a 7 inside, 1 minus 7 is minus 6. You cannot log of a negative number. Don't have such thing, not defined. Yesterday we discussed already, right? Okay, so you have to check your answer and reject. I guarantee you, your exam sure have this kind one, where you need to reject. So if you don't check now, you don't have the habit now, you will not get the full marks. Okay, so that's all for today. Thank you very much.